Hello everyone, my name is Irene Vogiatzaki and I represent my research work, which I did under the supervision of Mrs. Thessaloniki. The aim of this research is to explore current approaches to the reuse and recycling of construction materials in the building sector. Reuse and recycling are not new ideas. In the past, materials were often reused in construction. A well-known case is the work of Dimitris Pikiones, who reused materials from the demolition of 19th century houses for the landscape design around the Acropolis. However, today the situation is quite different. Construction mainly follows a linear model. Materials are produced, used, and then discarded. This model increases pressure on natural resources, leads to large amounts of waste. So for this reason, this research examines whether reuse and recycling can support a more sustainable approach to construction. The research is based on a combination of methods. An important tool used in this research is the concept of embodied energy, along with life cycle assessment, which helps evaluate environmental impact. In this context, construction and demolition waste plays a key role. Its management aims to bring materials back into the economic circle. Based on this approach, the circular economy focuses not only on recycling, but also on keeping materials in use for longer. Key strategies include design for disassembly, selective demolition, extending building's life, and the use of high-quality recycled materials. In this context, it is important to examine how different construction materials can actually be recycled and reused in practice. Starting with concrete, recycled concrete can be used in many applications, such as foundations, road construction, and infrastructure projects. The recycling process includes collecting, sorting, cleaning, crushing, and finally use of the material. However, there are some challenges, such as the need for high material purity and variations in the quality of aggregates. Moving to metals, steel and iron can be easily separated using magnets, while non-ferrous metals require more advanced sorting techniques. Aluminium recycling is very efficient, as it can save up to 95% of the energy compared to primary production. Steel is also fully recyclable without loss of quality. As for glass, it is theoretically fully recyclable, but in practice it is rarely recycled in a systematic way. This is due to several challenges, such as the lack of organized collection systems, the need for proper separation, and the wide variety of glass types. Regarding wood, after recycling, it can be used to produce materials such as particle boards, MDF, cement boards, and composite materials. However, the process faces challenges, mainly due to impurities and contaminations. Also, about 15% of wood is considered hazardous because of previous chemical treatment. At the same time, research is developing new solutions. For example, studies show that wood waste can be used as insulation material or transformed into new bio-based products. Ceramic materials represent a large percentage of mineral waste in Europe. The recycling process includes crushing, sieving, and testing, so they can be used as recycled aggregates in concrete and mortars. A key challenge is the high water absorption, which can affect strength. However, research shows that up to 50% of natural aggregates can be replaced by ceramic waste with proper design. Finally, plaster is fully recyclable material as it keeps its properties unchanged. Today, many production units already use between 5 and 18% of recycled plaster, while pilot projects have reached up to 30% recycling. There is also potential for its use in cement production, further improving its environmental performances. Next, I'm going to present 6 case studies. These projects show successful integration of recycled and reused materials in construction, not only technically, but also in terms of design quality. A key example is the EinB Museum, designed by Wang Shou. This project is a strong example where reuse is part of both the function and the concept of the design. The building's outer shell is made from a wide range of materials collected from demolished traditional villages in the area. This approach is not only ecological, but also preserves the memory and identity of the place. Another example is the timber adaptive reuse theatre, which focuses on the reuse of wooden elements. In this project, the old industrial building is transformed into a space for cultural activities. The existing structure is preserved and wooden beams from the original building are removed, adapted, and then reused as architectural elements, such as panels and partitions. At the same time, engineered timber, such as silting and glulam from sustainable sources, is used to reduce environmental impact. The next example is an exhibition space based on an existing building. The original external walls are preserved and strengthened, while a new outer shell is created using recycled bricks from the previous structure. The complex curved form of this new facade could not be built with traditional methods. For this reason, robotic construction technologies was used, allowing a more advanced and contemporary design result. This project shows how reuse can combine with new technologies. Another case of reuse of ceramic tiles, the architect of this example reuses tiles from other buildings in the area and applies them in different ways. In some cases, the tiles are used as full surfaces, while in others they create semi-open structures. Because of no binding materials are used, the result allows light to pass through and creates different visual effects and spatial experiences. Finally, the Hellenic Visitor Center in Korea is an innovative example of concrete reuse. Fragments of concrete are used in garden walls, replacing natural stones. At the same time, semi-transparent tiles are used from recycled concrete, and new concrete elements are cast using fabric molds, creating textured and expressive surfaces. This example shows the flexibility of concrete, both in form and function. So, from this research, we can conclude that reuse and recycling plays an important role in sustainable construction. Reuse requires less energy than new production, while recycling helps reduce raw material use. However, the biggest impact comes from considering the whole life cycle of a building, from production to final reuse or disposal. At the same time, there are some limitations, such as energy use and material quality loss, but overall, a holistic approach is necessary to achieve a more sustainable built environment. Thank you.